Değerli konuklar, sıradaki konuşmacımız Sayın Ilan Adler. Doktor Adler, çiftçiler ve kırsal topluluklar için atıkların enerjiye dönüştürülmesi veya güneşe dayalı su arıtma sistemleri gibi uygun ekoteknolojiler yoluyla yerel koşulların iyileştirilmesine adanmış bir sosyal gelişim olan Economad Solutions'ın CEO'su ve kurucusudur. Bir Kraliyet Mühendislik Akademisi işletme üyesi ve aynı zamanda yağmur suyu hasadı teknolojilerinde doktorasını yaptığı University College London'da çevre mühendisliği tasarım bölümünde temel öğretim görevlisidir. Halen mühendislik ve uluslararası kalkınma yüksek lisans direktörü olarak görev yapmaktadır. University College London Uluslararası Kalkınma için Mühendislik Yüksek Lisans Programı Direktörü Sayın Doktor Ilan Adler'i merkezsel olmayan ekoteknolojiler vasıtası ile kırsal kalkınma konulu sunumunu yapmak için davet ediyorum.
Hello, sorry, I'm a bit taller, so I'll have to raise this. Good afternoon, everyone. I see that we are the survivors here of the afternoon. The group keeps shrinking. So I got today in at 1 in the morning from London, so apologies if I'm not in the best peak condition, but we'll do our best to keep going through this great half an hour and explain a bit of all the work that we've been doing in different groups. So, as it says there, my name is Ilan Adler. I have several hats. So I'm an academic on one side. I work at University College London. I've been there for 10 years. I did my PhD there. And then also, at the moment, I'm the director of a master's program. The master's is called Engineering for International Development. It's a very successful program. We attract people pretty much from everywhere, all over the world. We still haven't had anyone from North Cyprus, and we'd strongly like to encourage you to apply to our MSc program as well to keep on diversifying. I did bring, by the way, some brochures about the master's program, so I'll put them out. I'll give them to Abdullah, probably put them out tomorrow, so if you have more queries from the academic side of things. It's a very interesting program because it's very hands-on. We created a module, which I will talk about today, which is my main field of expertise, called Appropriate Technologies in Practice. So we teach people to actually design and build things, and they engage with NGOs all over the world and do real-life projects. And then we also have a trip to Wales, to a place called the Centre for Alternative Technology, which some of you may not have heard of Wales, but it's also another country within a country, interesting political situation, a bit like Northern Ireland. So we take our students there, spend a week, and do lots of great work in micro-hydro, renewables, and so on. So let's jump into my lecture. I just want to say that before I was into environmental science, engineering, I have a mixed background. I come from Mexico, but before being from Mexico, I was actually from Venezuela, a country in South America. Some of you may have heard about it, very conflicted, controversial nowadays. But in those days, I wanted to study environmental engineering, but it didn't exist. So I studied electrical engineering, so that's my main background, electrical. But right after graduating, I didn't really find a job in electrical engineering, so I worked, and you won't believe this, as a translator, English to Spanish. So before I begin all my talk, I just want to say I have great, great sympathy for the people in that cabin over there, because I actually used to do pretty much that, and it's a very difficult job. It's a bit like the people who take care of maintenance. When they're not there, you realize they're not there, but when they're there, you just don't think about it. So thank you very much to our wonderful translators in the cabin there. Okay, so jumping in. After being in academia for a few years, I started a company called Economad Solutions, and basically it seeks to get a lot of the research we've been doing at UCL, which I'll talk about in a few minutes, getting it down to business, to social enterprise, to communities, to real life. At the end of the talk, I'll give you a bit of my own background, because before all of this in Mexico, I actually started a few companies and an NGO as well. So as I said, my background is quite mixed and confusing, but it brings together quite a few experiences, which are it can be a nice thing in this context. Okay, so jumping into the company, the focus of my talk will be mostly about the business opportunities and aspect, because I see the topic of the conference today is about green business, rather than just being a dry, boring academic research lecture, which I've done lots, and I can definitely do quite a bit of that. Economed was born thanks to a Royal Academy of Engineering fellowship. In the UK, we have this thing called fellowships. Not sure if Cyprus has the equivalent. In every country it's a bit different, but it's basically 1 year of funding from the government that you get as an academic, where you don't have to teach. It's basically like being in heaven, and you get paid to do your own project. You're obviously very competitive, you have to apply, and the Royal Academy of Engineering sponsored me to create this spin-out, or this company linked to the university, which also has quite a bit of R&D, research and development of technology around it. So right now I have both positions. We're involved in the company and that. The company gets also funding right now from the European Union through the European Regional Development Fund. So let's start right away. So the main focus of Economic Solutions is not my only field of research, but it's a very important field of research, is basically small-scale technologies which can be applied in a decentralized level, on a very small-scale level. You can go from very small to, not as small or medium scale, and they can be done also off-grid. We just had a talk, it was really interesting to hear Sam talking about anaerobic digestion and so on. So I'm also going to talk about anaerobic digestion, which for those of you who don't know is basically waste to energy. But there's a big difference. We are not talking about huge national government plans, we're not talking about big megawatt plants, we're talking about really, really small installations that can be done by anyone, anywhere in the world, who has a few animals in the backyard or has a bit of waste and can put them into this reactor and get some gas for cooking or doing heating or even electricity, and producing their own fertilizer. Very, very high value, the fertilizer. One of the fields that Economed is working right now is bringing a technology which we actually developed in Mexico, bringing it to the European Union, to the UK. So basically, let's talk very briefly about livestock and farming, not just small scale, but in general. We all know that agricultural waste amounts for about 10% of greenhouse gas emissions. We've all heard about, manure, waste from animals. Manure is a nice word to say another word. It's basically waste. Coming from animals, produces huge amounts of methane, for example, and there's CO2 emissions, and there's lots and lots of emissions, nitrogen, etc., related to agricultural waste in general. The EU, very interesting, 1.4 billion tons of manure per year. I mean, that would fill many, many, many football stadiums probably every minute with manure. So just have an idea of the scale of the problem. And of course, there are increasing pressures on land use. The United Kingdom, particularly where I'm living, London, the southeast of England, is very dense. And there's still a lot of farming, but there's not enough place to put all these wastes. We can't afford to have gigantic slurry pits. Slurry pits is a place where all these wastes used to go to traditionally, or landfills for other types of waste. So land is becoming a big problem, and people are living closer and closer and closer to the farms. So smells, ammonia, CO2 emissions are becoming a major problem. So this is putting a lot of pressure with as we heard from the other speaker, with increasing density of population. So this is all good and it's all very well understood, but then we get to small farms. So you might think that small farms, or what we call small holdings in the UK, normally I speak very fast. I'm trying to speak slowly for the sake of my colleagues. Basically, the thing with small farms is people don't really know this, but over 90% of farms in the UK and in the European Union are what we call small holdings. Now, small holdings can be 1 acre, for example, or a couple of hectares. I mean, hectares, really small plots of land. Usually they're owned by one family, a single family owns them, and they will most likely have 100, if they have livestock, animals, they'll have 100 animals or less, be it pigs, cows, sheep, etc. So we tend to think agriculture, yes, sadly in some cases it is growing and becoming into very big conglomerates. We keep hearing about Monsanto and so on, but still we have 90% of farms, or more actually in many countries, are tiny, tiny farms. If you just travel through the countryside in the UK, it's one after the other, really small farms. And what happens with what Sam was mentioning with AD is it doesn't get to the really little guys. We saw some of the photos there, it's a big concrete, huge installation, It's a plant, basically. Even if it's on the farm, it needs a lot of engineering, a lot of regulations, a lot of permissions. So what our challenge was, how can we actually bring this AD in a lot smaller scales, and also in a more DIY, more do-it-yourself approach. Again, this is something we learned with many years doing it in Latin America, in Africa, India, and so on, but not so much actually around here in what we call the so-called developed world. So as we say here, alternative treatment systems like big anaerobic digestion plants are hard to obtain. They're becoming more and more difficult in the UK. With this government, there's a big danger to incentives, for example, for anaerobic digestion. They're being phased out. We don't know what's the future. It's completely uncertain. So it's becoming more difficult. Maybe the Northern Ireland reality is slightly different, but at least in England it's becoming quite difficult to commission new AD plants right now. And what happens is that the current practices, we did a very interesting survey over 50 farms in a place called East Anglia, so that's like the south bit of England, but more like the eastern, where there's lots and lots of farmings. It's actually quite interesting. These small farms, which as I said are about 180,000 just in the UK, they will incinerate waste, some of them. They don't know what to do with it. They will give it for free to the neighbors so they can spray it on the land. Some of them will put it in a big compost pile, which is really, really smelly. If you live close to other residential areas, it brings lots of problems, bugs, mosquitoes, etc. When it's composted enough, they'll spray it on the land, which is quite an inefficient way actually of getting nutrients back into the soil, because it goes on the surface and you lose a lot of the ammonia, so you lose a lot of the nutrients. So that's one way that people do it, and other solutions are put it in a big pit, a gigantic like lagoon, very stinky, very smelly, like a slurry pit is the word we use. Some of them are covered, some are not, so most of these practices are quite inadequate. So that's why we set out to do these mini anaerobic digesters. Okay, so let's keep going here. So we saw this as, first of all, I'm gonna just back off a little, go back a little bit in history. When I was in Mexico, as I was saying, I started an NGO. I'll show all the links at the end, and hopefully you'll get copies of this, or you can talk to me if you're more interested. The NGO keeps on going. It's been going for 15 years, the International Renewable Resources Institute. And the NGO was really dedicated to promoting what we call eco-technologies, or appropriate technologies. So we did rainwater harvesting in the slums, the peri-urban areas, which, for example, Mexico City, millions and millions of people live in informal housing or slums. And so we started doing rainwater harvesting projects, which were very modular, very easy to do. And now that program has rolled out to more than 10,000 homes around Mexico City that have it. We started doing in rural areas as well. My PhD was based on rainwater harvesting. You can do a PhD on rainwater harvesting. It sounds weird, but you can. And then we started working in other technologies like small-scale solar, solar thermal, biogas, and so on. So we created this biogas program, and then through the NGO spin-out, a company was born. The company is called Sistema Biobolsa, or now it's international, so we have presence in 3 continents. It's in India, Kenya, in Africa, and in Latin America, 3 different countries. And basically we roll out a very standardized small-scale biodigester, which I'll show you pictures of in a moment. And it's really quick and easy to install. Many small farmers. In Mexico, I don't know about North Cyprus, but Mexico we have something called backyard farming. It means there might be, many times it's women who do it. The men migrate to the US many times, or the big cities. So for example, a lady might have 3 pigs or 1 cow in the backyard, or a few chickens, as simple as that. And this is a survival mode for many parts of Latin America, or the developing world, Africa the same. So we designed a system where even that small, you could put it out there and then start getting all your gas for cooking, and you didn't have to use any more firewood, any more coal or other more polluting fuels, or have to pay a lot of money for gas to be delivered in a container, which is what happens in rural areas. So what we've been doing the past few years is bringing this technology to the UK. Interesting, because normally technology goes north to south, but we decided to do south to north. But of course we have input from UK researchers as well. But the core technology actually, and the prototypes, even the manufacturing, most of it is done right now in Mexico. So it's not in China, but in Mexico, which is probably different than what many people are doing. So we decided, let's do something that can be done in the European Union, in a developed country, that's affordable, can create some extra money, and is most importantly, simple to install and operate. So not an AD plant, which is centralized and needs lots of farmers to agree on it, with lots of controversy. No food for energy, so we don't do AD plants that are even big enough or even designed for you to grow a crop to feed into a digester, which is what happens a lot in Europe. For example, I went to Germany to visit like 10 AD plants, and it's a major controversy because people are growing maize, which probably could be used to grow other things just to do energy crops. There is a positive argument in favor of that, but there's also a lot of negative arguments. You need lots of fertilizer, you're displacing land that could be used for other things, and so on. So we are just doing a waste treatment machine, basically, that you can put on site and then get all the benefits. So let's look a little bit of how what we call our ecosystem works. The company is called EcoNomad. The product itself, which is coming to the market next year. For now, we just got the grant to start one of our big-scale trials. When I say big scale, I mean like, you know, in an actual farm in the UK, which is operating, because we have trials on urban farms, which are even smaller, and they're great because they demonstrate the technology. People can go, they can see the gas, we bring kids from schools, we do barbecues of biogas, but this one is going to be an operating system, which is a lot closer to market. And at the center is this product that we call the BioNomad. So it's quite interesting because it's not just a biodigester, it's actually a lot, maybe that can be our slogan, not just a biodigester. We basically have a greenhouse. At the end I'll show you some photographs, pictures, and inside the greenhouse there is a biodigester, so it's a treatment system. The greenhouse itself is growing food. You know, there's crops, tomatoes, and so on, which grow in a greenhouse in the UK. We are using the liquid, oh sorry, I don't know if this has a laser pointer. Which one? Oh, the back? Will it kill anyone? Okay, no, it doesn't work. All right, no worries. So that's fine, you get the picture. The thing at the center, basically, the biodigester gets product on one end, which is basically waste products. It could be food as well, although mostly we work with manure. It could be even human manure, and so we have done a few examples, but here for now we're focusing on farms. At the other end, because it stays in there for enough days for it to degrade, and then we get the gas. At the other end, we get a very rich liquid, which is digested. We call it digestate. In Mexico, we call it biol, B-I-O-L, like a biological product. And that biol is very, very rich in nitrogen, phosphorus, like things that farmers pay good money for, and we get it for free from this unit in a nice, digested, soluble liquid form. So we use those to accelerate compost piles, because that's one very interesting research we've done at UCL. And we also use it to grow food inside the greenhouse. So it all stays in that ecosystem. The biodigester needs temperature to operate, but it also produces a bit of temperature because of the bacteria inside. So by having everything contained in the greenhouse, we give it some heat because of the greenhouse, but we also recover some of its heat for the plants and so on. The compost that we have inside will also produce extra heat that we can then use inside the greenhouse. Then we complement this with a bunch of things that I've been involved in for many years. One is rainwater harvesting. As I said, this is a field that I've been working in for about 15 years. When I was in Mexico, I didn't only do small little projects for villages. We also did, for example, the Ministry of the Environment, Mexico City, is all let's say, supplied by a rainwater harvesting system, which I designed and implemented through a company in 2005. And we did projects in Walmart, the headquarters, in Holiday Inns. We did it in factories, in big food factories, and so on. So rainwater harvesting is something that I was working in for quite a while. But here, we're looking into using the same modular technology for designing modular tanks. So right now, our biodigesters are made of a type of geomembrane, so they're flexible. So with the same technology, we've managed to manufacture these very quick tanks that you can put up, which are a bit different than other quick tanks in the market. And the idea is that we will be offering all of these integrated solutions. So you need water to operate the biodigester, so we can get as much as possible from rainwater storage. Not 100%, but as much as possible. On the right-hand side, you will see something called passive solar pump. So this is actually a patented product, which we've been working on for the last 5 years. And this is really a UK innovation. So it's a type of solar pump for pumping water or liquid that doesn't need solar panels. I know it sounds a bit weird. Most solar pumps today have a photovoltaic panel and then they have an engine. But our product actually works with heat, so it's what we call a thermal pump. I'm not going to get into the engineering of it because it would be quite complex to explain, but basically the point is with a lot less technology, a lot more affordable, without using any electronics, any moving parts, you actually create a pump that can lift water up to 10 meters high, and it can be locally manufactured, very, very simple. We just applied to an Innovate UK grant, the Energy Catalyst, to develop this in Ethiopia. I was just in Ethiopia last month, actually. So I'm leading a grant where we're going to trial some of these units in Ethiopia, and we've already done trials in Mexico. And believe it or not, in the UK, in this summer we actually had very good sunlight, so we managed to do some very good testing. The problem with the UK is it's October, and when we try to do tests now, it's gone, no? So we have to use lamps and solar simulation, which is not much fun, really. So, but Northern Cyprus is a very good place. You have lots of sunshine, so we're very open to discussing collaborations for doing field trials, for example, no? in places like these. The interesting thing of the solar pump is it actually builds in a solar pasteurizer, which we've tested extensively in the lab with really, really good results. So what does it mean, a solar pasteurizer? The same energy coming from the sun that is lifting the water up is also disinfecting it as it goes along, making the water reach to the standard of solar pasteurization, 70 to 75 degrees for a long enough time, and then you get water that's basically purified. We tried with E. coli with very high doses. We're doing some tests with viruses as well, and it's very, very effective. So we want to actually use that to pasteurize the liquid that comes out of a biodigester. Why do we want to do that? Because in the UK, if a farmer now has his liquid, which is very rich, he is allowed, there is something called a T24 exemption. You are allowed to use it in your own land, that's fine, for certain crops. Because it's still, the biodigester treats waste, but it still has some bacteria, some risk. But if they pasteurize it, and there is guidelines of how to, what that means, they can then sell it for a very good premium, very good value. It can even be sold in shops, for example, or bottled for gardens in the city. And then you create these farms which are really struggling for cash. You give them another revenue stream. So we are looking into ways to integrate these two things. Then we're also working on a few other innovations with the University of Rothamsted. Rothamsted Research is the oldest agricultural university in the world. Actually, it's just 1 hour away from London, and we have a very strong collaboration with them, and we're working on some technologies for extracting more energy of the biogas, which we could talk about later if we had time. So all these things integrated make a very nice, optimized biodigester, but the core of the unit is still quite simple at the end of the day. Okay, so let's look at, sorry, I'm not very good at timekeeping, so that's really good. Let me just, yeah. Let's look a little bit at the benefits. So this is just an exercise. We realize that, somebody who has 10 cows, for example, in the UK, producing 200 cubic meters of manure per year, that's a lot of manure. And then collecting this much rainwater can actually run the unit and then produce about, 15,000 kilowatt hours of biogas, which has roughly that monetary equivalent. If he sold the fertilizer or even replaced the nitrogen that he would have had to buy, then there's all these benefits, and then we save money in some farms in disposal costs. Some farms closer to cities have to pay quite a bit of money to get rid of waste. For example, horse stables. We're working now with people who have horses, and horses are premium stables. Usually they're closer to cities. People who have lots of money will own horses, but they will pay a farmer to keep the horses for them. So horses don't like having manure where they are walking around. Like cows don't mind, but horses do. So people have to actually pay a lot of money to get rid of this waste because they just simply don't have space. So we would save all that money, and we did some exercises you can pay back in 2 or 3 years. So here's a bit of figures which are interesting. So in the UK we have eligible for a product like ours about 124,000 farms, smallholding farms. The rest of the European Union, about 5.2 million farms, so it's an opportunity. Obviously, it's not the easiest market in the world, but it's still quite interesting. And in terms of impact and climate change, it's huge what you can do, because a biodigester, all that methane that would have been released to the atmosphere, you capture it, you burn it, and you produce electricity with it, and reduce tremendously its greenhouse gas potential. So this is a bit of the things we've been doing. So we got funding from the European Regional Development Fund, as I was saying, also from the Royal Academy of Engineering and Enterprise Fellowship. And we're starting these pilots September, October, and the idea is then we're going to do 3 to 5 more units in Wales, Scotland mostly, hopefully in Northern Ireland if we get the right contacts at some point. And then hopefully try to get this to market, maybe not April, maybe a bit later. And yeah, we're very open for discussing with people here in Cyprus also opportunities for doing trials and so on in small-scale farms. We're also working quite a bit on data services. That's very interesting. We partner with another company called Connected Energy. So we're developing interesting, and also the electrical engineering department at our university, developing IoT, so very low-cost sensors that can be put to detect how much biogas is being produced, feed that to a central database, how much liquid, how much water was required, how much rainwater was collected, and then with that data, maybe look into things like trading or other financial schemes, where, for example, a farmer can not necessarily have the money to buy the unit, they can maybe get it as a lease, but then through our IoT of our measuring their gas production, they can be paying per gas produced. So these are models we're exploring for the future, trying to learn a bit from the solar industry in a more complex field, which is biogas, and where you have gases and so on. But that's also something we are working into quite a bit right now. And then just to end was a bit our team of people working in this. But I want to just skip very quickly, because we only have a few minutes left, to show you the most exciting bit, which is some photos. So this is all in London, by the way. None of this is actually in Mexico. So sorry, except the photo in the middle. The one in the middle is I think it's Mexico or Colombia, but it's a Latin American reactor. So as you can see, it's like a bag. It comes rolled up. And then you just unroll it, plug it in. Initially, when I started more than 10 years ago, it used to be like greenhouse plastic bags, and it was all made with whatever rubber ties, whatever we found. Now we do it in a more nice industrial scale, but it's the same principle. It's certified to last for at least 25 years, and if you protect it from sunlight, maybe even more, maybe 50 years. So while it is a plastic, it's a very durable product, because the problem with plastics mostly is a single-use problem. If we create products that are very, very durable, that will be there for 50 years, then the problem is quite different. So, it's not an excuse for plastic. I'm just saying that there's a difference between something durable and the single use. What you can see in the lower right-hand corner is us extracting energy from compost. Super interesting. So we have compost. If any one of you does compost in your house, you know, you put your food, I do it in my house, and I live in an 80 square meter home. We're talking about small homes. In London, you can't really afford a 500 square meter home. If I could afford a 500 square meter home, I wouldn't really be here. I would be, you know, who knows where. Okay, so basically, maybe I still would be here. We are extracting heat through these pipes and then sending the heat back to our biodigester through compost piles. Very interesting innovation. Finally, we have some of our solar pumping and pasteurization experiments. These are still just prototypes. The ones on the lower right are students of mine who travel to Mexico, master's level students. We have set projects with NGOs, Engineers Without Borders, and other groups who travel and implement. We're working with evacuated tubes for places like Britain that don't have much sunlight, but we can have very efficient technology to do a thing like that. So yeah, and this is just to give you a rough idea. Those up on the top left are pasteurization experiments where we inoculate with very heavy amounts of bacteria. We let it run with even in London with sunlight, and then we collect like zero bacteria, complete removal of coliforms. So far promising good results, but still a lot of work to be done. So that's about it for me. Here's some of the partners we work with. As I said, Erie, Mexico is the NGO that I founded quite a long time ago. Our prototypes in London are in Surrey Docks Farm, an urban farm. And Rothamsted, right in the middle, is where we got the European Regional Development Fund grants. I think that's about half an hour. Is that right? So thank you very much. If you have any questions, I'll be around. Yeah. And thank you very much. Yeah. Wow, you're the first question of the whole group.
You have a brilliant project down there, which I appreciate very much. But unfortunately, the people living in Cyprus, we are living in hot climates. Thank you for your presentation. As far as I understood, it is applicable to countries with cold weather like UK, London, etc. Is it applicable to hot climates?
Okay, sorry, maybe I should clarify. It's exactly the other way around. It was all designed for hot climates, That's where our company in Mexico is. And what we are doing in the UK is adapting it to cold climate. But the initial product is made for hot climates. It works very well in warm climates. So Cyprus is easier for us in many ways. And it is actually a really good opportunity. It's a lot less challenging for us to work here than to work in the UK. So yeah.
Thanks.
Okay. So by all means, we're very happy to hear about opportunities to start working on this. Any other questions? Glad to break the ice because maybe in the UK people are very opinionated. There's always lots of questions at the end. And so by all means, if you have any other questions, if not, I'll be around. So by all means, we can have a chat later.